supersonic.
Supersonic.
Supersonic jets could be making a comeback nearly 20 years after the Concorde stopped flying.
A new supersonic aircraft could take its first flight as early as 2021.
Speed has long been the defining marker in the ongoing evolution of aviation, setting the boundaries of technological achievement, mission effectiveness, and even national influence. Throughout the 20th century, the push toward faster flight fueled innovation, spurring competition, arming nations, and inspiring generations. World War II's iconic dogfights and transatlantic bomber sorties proved that reach could redefine strategy. Yet the post-war jet age and the advent of supersonic aircraft established new ambitions, forever accelerating the pace of aerial warfare and commercial transit. But as technology charged forward, barriers swiftly appeared. The advent of supersonic travel brought not only stunning velocity, but also the disruptive side effect of tremendous noise. For military and civilian operators alike, precision, safety, comfort, and above all silence quickly became urgent priorities. Now, as advanced supersonic projects gain momentum, the idea of traveling from New York to Paris or London in under 4 hours, once dismissed as far-fetched, edges ever closer to feasibility. The entrepreneurial world, with private jets like Spike Aerospace's S512 Diplomat, is moving to merge executive comfort with previously inconceivable speed. In parallel, NASA's experimental X-59, a one-of-a-kind supersonic jet, is advancing along its developmental milestones, promising not only velocity, but a significant reduction in the acoustic signature historically associated with these feats of engineering. This moment, therefore, does not represent a return to the era of the sonic boom-laden Concorde, but rather the genesis of a new phase, one that prioritizes breakthrough quietness as much as raw speed. Speed, silence, and the sonic shadow. Supersonic flight has for decades represented mastery over one of physics' most envied boundaries. The Concorde's iconic silhouette, slicing the hours from transatlantic journeys, defined public imagination in the latter part of the last century. Faster military jets shaped strategies and tactics, bringing far-flung corners of conflict within reach at speeds that could change the course of events in a matter of hours. Yet all this advancement was tempered by the inescapable byproduct of supersonic travel, the sonic boom. As planes move faster than the speed of sound, they generate shock waves, a thunder-like explosion that reverberates along their entire trajectory. This effect is more than a minor inconvenience. It has posed real obstacles for both public acceptance and regulatory approval, resulting in strict limitations on where such aircraft may venture. Civilian supersonic flight over populated land masses has been banned in the United States for decades, with military aircraft also having to operate with care when approaching civilian regions. Concorde was able to reduce transatlantic journey times, but could never fully avoid the sonic disturbance that accompanied its performance. Military supersonic operations similarly required compromise. Either accept the reduced element of surprise and possibility of social disruption, or operate below the speed of sound until clear of sensitive areas. These limits have profoundly shaped the operational envelope for both commercial and military aviation. The perennial desire for speed endured, however. Engineers and strategists continued seeking methods for achieving supersonic travel without inflicting the disruptive sonic booms that provoked public outcry, diplomatic negotiation, and legal barriers. The X-59, NASA's quiet supersonic research aircraft. It is within this context that NASA's X-59 quiet supersonic research aircraft emerges. Unlike any prior project, the X-59's mission aims not simply at surpassing Mach 1, as routine as that now is for military aircraft, but at rendering the supersonic shockwave unobtrusive, reducing it from a boom to what has been described as a sonic thump. This subtle but vital distinction is at the core of NASA's initiative, a future where speed and community peace may coexist. Dubbed by some as the Son of Concorde, the X-59 represents the result of both regulatory momentum and technical ingenuity. At the heart of its design lies an ambitious challenge to meet legal and public demands for a quieter supersonic experience. The development process reflects this focus. NASA's engineers have meticulously shaped every aspect of the X-59, from its extended needle-like nose designed to disperse shock waves to its overall aerodynamic configuration, which channels those waves in directions that minimize their perceived intensity at ground level. Engine placement, set atop the fuselage rather than beneath it, plays a critical role in dissipating noise. Every detail, from wing sweep to control surface tuning, serves a singular mandate: reduce audibility of the supersonic transition. This is not a mere theoretical project. The X-59 has recently completed its first crucial taxi tests on a California runway, moving under its own power for the first time, a major achievement signaling readiness for further ground and, soon, air trials. These taxi tests are the necessary forerunner to flight trials set for 2025, during which the X-59 will demonstrate in air the principles proven in wind tunnels and computer simulations. A platform for the future, but not an operational weapon. Importantly, the X-59 is not itself destined for frontline military or commercial service. Rather, it is a research platform, a sophisticated flying laboratory intended to gather crucial data and validate concepts that may eventually transform both commercial air travel and the future development of military aircraft. If the technology works as expected, future designers will be empowered to create supersonic jets, potentially including bombers or executive transports, that can operate at top speed without subjecting communities below to deafening booms. In strategic terms, the implications are considerable, but realization will depend on additional research, public acceptance, and the evolution of aerospace manufacturing. US policy and regulatory change paving the way. Any breakthrough in aerodynamics must ultimately be matched by change in airspace regulations, which have long prohibited civilian supersonic flight over land in the United States. That barrier, a product of past experience with the disruptive effects of sonic booms, has stymied development and deployment of commercial supersonic aircraft for decades. In this arena, 2025 marks a potential turning point. According to the most recent developments, an executive order from President Trump in June 2025 directs the Federal Aviation Administration to lift the ban on civilian supersonic flight over land, clearing a path for NASA's X-59 project to perform its core mission, flying at supersonic speeds over US cities to collect data on the public's perception of its new, quieter acoustic signature. This regulatory development is neither trivial nor isolated. It is a calculated response to the convergence of technological and societal readiness. It links NASA's technical progress to real-world, policy-driven opportunity, enabling the necessary large-scale trials that will define whether supersonic travel can become a routine part of American and global aviation once again. NASA's community response flights, the crucial experiment. NASA's plan for the X-59 is both scientific and civic. Once flight testing begins in earnest, the aircraft will overfly select US cities at speeds up to 1,510 kilometers per hour, Mach 1.25, well above the sound barrier. The flights are designed to measure the X-59's impact on people below, not just in objective terms of decibel level and frequency, but as a lived experience for residents under the test corridors. Throughout these flights, sophisticated acoustic sensors will be deployed on the ground beneath the aircraft's path, capturing data on sound intensity and character. Simultaneously, surveys will be distributed to residents, collecting feedback on whether the softer supersonic thump was noticeable, disruptive, or within the bounds of everyday urban life. These community response flights are a pivotally important step. The input gathered will not only shape regulatory decisions, but will also guide future design choices for both commercial jets and possible military derivatives. Success will be defined as much by public tolerance and acceptance as by technical accomplishment. The broader impact, implications for commercial and military aviation. If NASA's work with the X-59 is successful, commercial aviation could enter a new era, The return of viable supersonic flight on major routes, untethered from overwater-only limitations, could slash travel times and revitalize transcontinental air travel. Projects like Spike Aerospace's S512 Diplomat, which are separately under development with aims of high-speed, high-comfort jet travel for private and business clientele, could benefit directly from data and design advances pioneered by NASA. In the military arena, the technical lessons gleaned from X-59 testing, particularly how to dampen or distribute shockwaves, could have important implications for future surveillance and strike aircraft. While the X-59 was not conceived as a bomber or weapon system, its success could inform the basic airframe contours and operating concepts of future platforms that seek to combine supersonic reach with minimum notice. However, it is key to reiterate that, per the current state of development and as supported by facts, there is no operational plan or prototype for a supersonic bomber that could cross the globe in 2 hours. Such timelines, while theoretically possible for very high hypersonic vehicles, are outside the current capabilities of both the X-59 and contemporary jet aircraft development. The X-59's targeted test speeds are roughly Mach 1.25, suitable for transcontinental and transatlantic flight times, significantly shorter than current commercial jets, but not on a global circumnavigational 2-hour scale. Refining aircraft design, engineering for silence. The X-59's most notable design innovation is its elongated nose, accounting for nearly a third of its full length. This feature is not simply aesthetic. It is a precisely calculated intervention that diffuses shock waves, spreading them in a way that mitigates the spike in pressure that otherwise produces the classic sonic boom. Its engines, positioned atop the fuselage, are shielded from the ground, further reducing noise transmission. The wings have been sculpted for both aerodynamic efficiency and the optimal distribution of pressure disturbances. While radar and thermal signature reduction are focus areas in military design, such as with modern stealth bombers, the X-59's principal contribution is in shaping how future aircraft may travel faster without raising alarm via excessive sound, the acoustic stealth aspect. Operationalizing these technologies, training, flight profiles, and public communication. For pilots, operating a precisely tuned aircraft like the X-59 is a test of both skill and discipline. The airplane's avionics and sensor loads must constantly monitor not only trajectory, altitude, and airspeed, but also parameters influencing the creation and propagation of shock waves, ambient temperature, humidity, wind. Minor deviations can mean the difference between a nearly imperceptible thump and the kind of noise that would undermine the entire supersonic project. Integrating these technologies into future operational aircraft, whether for military or commercial use, will demand significant retraining and new operating procedures. Advanced simulation, feedback on acoustic impacts, and careful coordination with ground-based noise monitoring may become routine elements of supersonic aviation. Public acceptance and understanding will also be central. Even advanced, well-designed aircraft will be challenged unless the communities under their flight paths are adequately informed about what to expect and have opportunities to express concerns and offer feedback. NASA's commitment to studying not simply the engineering, but the social reception of its quiet, supersonic missions is thus a forward-looking approach in harmonizing technological progress with human realities. A technological pathway, not an immediate revolution. It is important to temper expectations. While the X-59 is poised to blaze a trail for a new generation of quieter, faster aircraft, its impact will unfold over time, across further flight tests, design iterations, regulatory reviews, and possible adoption by both commercial and military sectors. There is currently no quiet supersonic bomber ready for operational deployment, nor a global strike platform able to traverse the planet in 2 hours. The realistic, near-term impact of the X-59 and other advanced supersonic efforts will be felt first in regulatory changes, demonstrator flights, and foundational insights that may enable faster, more efficient commercial and strategic transport. The strategic horizon. changing the global aviation landscape. Nevertheless, if the X-59's principles are validated through test flights and followed by broad regulatory acceptance, the implications will be significant. The return of supersonic routes for civilian travel would mark the first major shift in commercial aviation speed since the Concorde era. Such routes, New York to Paris in under 4 hours, would transform business, trade, and personal mobility. For military planners, quiet supersonic flight would offer expanded flexibility, allowing rapid movement across continents with less risk of detection by acoustic sensors or civilian populations. Missions could be more responsive, with reduced warning possible for adversaries. If integrated with stealth, communication, and advanced propulsion systems, future aircraft may be able to fulfill missions that are currently only conceptual. However, these advances hinge squarely on widespread societal acceptance. Public response to the X-59's test flights, as monitored via NASA's intensive surveying and sensor campaigns, will have the final say in how quickly or broadly such technologies are put into practice. The sonic thump must prove not just quieter in laboratory terms, but truly tolerable or even unnoticed by residents beneath the flight path. Looking forward, a measured march toward supersonic renewal. The story of the X-59, then, is not simply a tale of engineering daring. It represents the intersection of aspiration, policy, public trust, and technical evolution. NASA's ongoing project is both a demonstration and a question posed to society. Can we embrace the next wave of high-speed flight if it no longer intrudes upon daily life with deafening sound? As the X-59 readies for its first supersonic flights over American cities in the coming year, the gathered data, resident feedback, and ensuing regulatory decisions will shape not just the future of this test vehicle, but potentially the evolution of aviation for decades to come. The age of the quiet supersonic jet is not a foregone conclusion, nor an overnight revolution. It is a careful, incremental process, one rooted in science, guided by feedback, and substantiated only as far as public acceptance and policy allow. Should its promise be fully realized, both the commercial and defense landscapes will be markedly changed, with new options for speed, strategy, and mobility. In sum, the X-59 stands poised to inform the next steps in aviation's storied quest for speed. Its influence will be measured not only in minutes saved across continents, but in the subtle transformation of how societies experience, regulate, and ultimately accept the rapid movement of people and material in an interconnected world. The long-anticipated return of supersonic flight, quieter and more considerate, may finally be at hand. It is a turning point that will unfold in the skies above and in the conversations below, as a new chapter in global aviation slowly, responsibly, and quietly takes wing.